The origins of Native Americans is still a hotly debated topic. Native Americans are modern Homo sapiens sapiens, and there is no evidence of any earlier forms of hominids existing in North America or South America. Only modern humans that appear to have migrated from Asia around 15,000 years ago and then spread throughout North and South America. All available evidence points to an ultimate source in the Old World, specifically northeastern Asia in Siberia. 3 lines of evidence support this conclusion: linguistics, physical anthropology, and archaeology. The article from Science magazine by Ted Goebel, Michael Waters, and Dennis O'Rourke that you are to have read reviews the genetic evidence and the archaeological evidence. And in the next lecture we will talk more about the genetic evidence. The linguistic evidence is sometimes called the Greenberg hypothesis, after the linguist who developed this theory, that there is an ancient single source for most Native American languages found in North and South America. That from this single source, over 11,000 years, there was diversification into the thousands of Native American languages found in North and South America. The next slide will show a map of the distribution of Native American languages and discuss this theory. Physical anthropology includes evidence from teeth and genetics. The evidence from teeth shows that Native Americans have similar tooth morphology in common with northeastern Asian populations, called cynodonty, with shoveled incisors and certain root structure of molars. Genetics from both mitochondrial and Y chromosome DNA, mitochondrial DNA providing a pure line of maternal descent, whereas Y chromosome DNA provides a pure line of paternal descent without any intermixture. Both lines of genetic evidence suggest Siberian origins of Native American populations no more than 30,000 years ago. However, some skeletal evidence suggests that the earliest human skeletons in the New World are more similar to Austronesian groups related to modern Polynesians than to modern Native Americans. Archaeological evidence indicates that Paleolithic cultures entered Siberia beginning about 32,000 years ago and spread into the northeastern part of Siberia adjacent to Alaska after 25,000 years ago. Flakestone technologies in these areas provide antecedents to early Paleo-Indian technologies. This map shows the distribution of the 3 broad classificatory groups of Native American languages proposed by Joseph Greenberg. The Amerind group that is found throughout North America and all the way down into South America. The Eskimo and Aleut group, in black, found in the Arctic from western Alaska across northern Canada and into Greenland. And the Na-Dene, or sometimes referred to as the Athabascan group, that's found in interior Alaska and northern Canada, as well as in the American Southwest. Greenberg suggests that all of the Amerind languages, which includes many different linguistic families, are related together, sharing similar aspects of grammar, morphology, syntax, and even certain aspects of vocabulary. These are distinct from the Eskimo, Aleut, and Athabascan language groups, which can also be associated archaeologically with later waves of migration across the Bering Strait after the land bridge had been submerged. Clovis is a culture found in North America that is believed to be one of the earliest in North America. Recent re-examination and reanalysis of radiocarbon dates from Clovis sites suggests that it dates to a very tight window of 400 years, between 13,200 to 12,800 years ago. Clovis is known for the projectile points that they manufactured, known as Clovis points. They are large, fluted points. The fluting is a large flake removed from both sides of the base to create a channel to assist the hafting of the point onto the shaft of the spear that will be used to propel it at the target. In the point shown at the top of the screen, you can see the flute coming in from the base and going upwards into the point. Clovis people were hunters of Columbian mammoth, and there are several known kill sites here in Arizona in the San Pedro River Valley, southeast of Phoenix. Clovis sites have also yielded remains of bison, horse, tapir, deer, rabbits, waterfowl, and turtle, as well as plants. Hunting of mammoth may have been an overwintering strategy. Killing a very large mammoth would provide a lot of food to be stored. It's very cold, perhaps like a perpetual deep freeze throughout the winter, so you don't even need a freezer to keep your meat. And it prevents you from having to travel outside during the cold winter and pursue animals through deep snowdrifts. The big question is, was Clovis first? For a long time, it was believed that Clovis represented the first immigrants from across the land bridge moving through the ice-free corridor. But current evidence suggests that Clovis were not first, but rather may have been the first indigenous culture to develop in the Americas. Clovis flakestone technology was very sophisticated and made very efficient use of the raw materials. They used two different types of reduction strategies in order to produce different types of tools for specialized purposes. They did biface reduction, where a core, like that in the upper right, was shaped in order to allow the removal of large flakes from either side. These large flakes could just be used as sharp edges to perform a variety of tasks and were unspecialized tools. As these bifacial cores were worked down, they turned into preforms that could be transformed into points. Other types of tools could be manufactured from the flakes in addition to unspecialized tools. And across the bottom we see different types of scrapers that were manufactured. Scrapers can be used to work a variety of materials, including wood, bone, but particularly hides. Scrapers were essential in transforming the hides of animals into soft and supple leather that could be turned into garments. At the bottom we see blade reduction, which is a very efficient use of raw materials and produce very standardized size long blades that can be transformed into different types of cutting and scraping implements. This blade reduction technology is very unique and is found only among Clovis. Blade reduction technology was independently developed much later among Arctic peoples who made microblades in order to have very light toolkits, and also it was independently developed in Mesoamerica in order to work obsidian and create standardized sized tools. This schematic shows how different types of cores, the material from which flakes or blades are going to be struck and then transformed into tools, could be manufactured from an initial cobble. On the left you see the transformation of the cobble into a core that is unidirectionally struck from a single direction to create these blades of a standardized size. And you just rotate the blade around in order to have new platforms upon which to strike and create new blades. On the right, the same type of cobble is transformed into a bifacial core. It is struck from two different sides in order to remove flakes in different directions, and this also thins the core, eventually creating a large biface that can be used as a cutting or chopping tool and then can be transformed at the end stage into a new projectile point. These photos of Clovis blades and cores show how there's an almost standardized size of blades struck off the same core, and also on the cores you can see the scars created by the removal of previous blades that are defined as the space between the ridges that you can see pronounced along the sides of the cores. When rotating the core around and preparing to strike to remove another blade, you would strike at the top of these ridges. So if you look at the blade that is the second from the right, you can see the ridge that follows along the top middle of the blade where it was struck off the core. So every time that you strike a flake, you create, or strike a blade, you create a new platform and ridge to strike to create the next round, and they will all be about the same size. When reducing the raw material this way, very little is wasted. Almost all of it is transformed into useful cutting edges. There is a very efficient use of these raw materials, which is important for highly mobile people who might be very distant from sources of these quality materials that are needed to make flakestone tools. This photo shows a Clovis point from 3 different perspectives, showing each of its sides as well as its profile. You can see on each side how the flake that is struck from the bottom going upwards into the point leaves a flute that you can see in profile is creating a thinner base, and it is even thinner towards the center of the point, which isn't fully captured in this photo. But this almost groove in the base of the point allows the point to be more easily attached or hafted to the shaft of the spear that is going to be used to propel the point into the target. These are replicas of Clovis points made by modern flint knappers, and in the Nova First Peoples of the Americas, we will see an archaeologist who reproduces Clovis points. But here they are shown as hafted onto a foreshaft, a small piece that will then be inserted into a socket on the main spear shaft. The main spear shaft is a well-engineered piece of equipment. It has been straightened, shaped, and you don't want to have to make many of those. It is easier to have a reloadable spear shaft with these sorts of foreshafts attached to the points. It also creates a multi-purpose tool, the foreshaft acting as a handle, so these could be used as knives after dispatching the animal that you are using them against. Clovis points and the spears they were attached to were likely propelled with an atlatl, or a throwing stick. In the Nova First Peoples of the Americas video, the same archaeologist who manufactures a Clovis point also will demonstrate how an atlatl is used to throw a spear. What an atlatl does is it extends the length of the arm, providing additional leverage and therefore increased projectile velocity. And we can conceptualize this in terms of a baseball pitch versus a tennis serve. The fastest baseball pitch is about 102 miles an hour, and most big league fastball pitchers can pitch in the upper 90s. However, a tennis serve, where a racket is used, an extension of the arm, which lengthens the arm, providing additional leverage, a tennis serve can be above 160 miles an hour, and the record is upwards of 220 miles per hour. So an atlatl allows a projectile to be thrown at a much greater velocity than by hand alone. The San Pedro River Valley of southeastern Arizona and northern Sonora has many known Clovis sites, most of which are mammoth kill sites. The site of Murray Springs, that we will see some photographs of the excavation of, is open to the public. It is on BLM land near modern Sierra Vista, and you can take a trail out to the excavation site, and there are interpretive signs discussing the site. The Clovis sites in the San Pedro Valley are associated with a particular geologic deposit known as the Pleistocene black mat. In this image you can see a horizontal band of very dark soil And this is an organic rich soil that formed in marshes that were created towards the end of the Pleistocene as the ice sheets were melting and adding more moisture to the environment. However, as the Pleistocene transitioned into the Holocene and modern dry environments emerged in the southwest, these marshes dried up, and this black mat is underlain by a white carbonate-rich layer called the coral marl. This is created as the moisture was evaporated out of the soils by the increasing aridity, leaving the dissolved calcium carbonates behind to create a caliche-like layer. Clovis sites in the San Pedro Valley are directly associated with this Pleistocene black mat. The Murray Springs Clovis site was found by archaeologist C. Vance Haynes in 1966. He and some of his colleagues would go out and revisit Clovis sites that were known of in the area and search for exposures of the black mat, seeking new sites. They knew to go out here because their advisor at the University of Arizona, Emil Houry, had found and excavated several sites in the 1930s, 40s, and 50s. The site was found as Haynes turned a corner and saw a mammoth tusk protruding from the sidewall, stratigraphically associated with the black mat deposits. A total of 5 mammoths were found at the site, and here we see archaeologists peeling back the black mat layer to expose the mammoth bones within. Here are several of the Clovis points that were recovered from the mammoth kills at Murray Springs. As you can see, many of them are completely whole and would have been reusable. They were likely so deep inside the mammoth's body that they were not recovered during the butchering process. The discoverer and excavator of the Murray Springs site, C. Vance Haynes, developed a model of the spread of Clovis, based on the assumption that there were 30 people in the first band, 5 unrelated families with 2 grandparents, 2 parents, and 2 children, and that within the population 1 in 4 made stone tools and made 5 points per month, and that there was a population increase of 1.2% in a generation of 28 years, which is a fairly conservative assumption based upon modern demographic data. It was also fairly conservative in that he suggested that they would only advance about 4 miles per year in expanding their range. Based upon these assumptions, within 500 years, depending upon rates of survivorship and reproduction, you could have between 800 to 12,500 people, within 26 to 425 hunting bands that would be spread over all of North America and much of Central America, leaving behind between 2 and 14 million Clovis points. Recent reassessment of Clovis radiocarbon dates suggests that the phenomenon spanned a 400-year period. And so the assumptions made by Haynes may be fairly reasonable to assume the expansion from an origin point that is now believed to be not in the far north, but rather in central Texas, across the entire North American continent and down into Central America. Based on a reanalysis of Clovis assemblages across North America, archaeologists Charlotte Beck and George Jones have proposed that Clovis originated somewhere in east or central Texas, and there are very early sites with Clovis materials and underlying pre-Clovis materials that suggest that Clovis did originate in this part of Texas, and then that Clovis spread northwest and northeastward from this area to spread across much of North America, also spreading to the south into Central America. At the same time that Clovis was emerging and beginning to spread, however, it appears there were also other peoples with a completely different flake stone technology that occupied the far western part of the United States, along the Pacific coast and in the Great Basin, where modern Nevada and Utah are. As the ice sheets in the Rocky Mountains and the Sierra Mountains melted, those that flowed eastward off the Sierra and westward off the Rockies entered into a basin, an area that had no outlet to the sea, and large lakes formed here. Remnants of these lakes can still be found at Great Salt Lake in Utah and Pyramid Lake in Nevada. These lakes supported large wetlands that supported populations of waterfowl and fish that could be exploited by prehistoric peoples. What is called the Western Pluvial Lakes tradition developed in this region and appears to be contemporary with Clovis and perhaps drawn from a completely different population bearing a different stone tool working technology. It dates between 13,200 years ago, the same oldest date of the Clovis span, but continues longer until about 11,400 years ago. And the earliest points within this tradition appear to be contemporaneous with Clovis. Unlike Clovis, they did not have fluted points, but rather they had points with constricting stems, some with shoulders, reflecting a different strategy used to create points in order to haft them onto spears. They also had a unique point form called a crescentic, which are very finely made crescent-shaped cutting devices that we're not sure exactly how they were used. They seem to have been put to diverse uses. Some of these crescentics have also been found at Clovis sites, indicating interaction between these two peoples. They had a diversified subsistence strategy along the shorelines of these Great Basin lakes, hunting deer, bighorn sheep, rabbits, waterfowl, and fishing, as well as collecting a variety of wild plants. This figure shows a variety of western stemmed points, points that are within this tradition. As you can see, rather than the fluting that was used to assist hafting of Clovis points, these taper to a narrower and skinnier basal end in order to assist the hafting of this sharp, pointy rock to a spear in order to allow it to be propelled at an animal target. The Western pluvial tradition also lacked the blade-based reduction strategy that Clovis people used, suggesting these are two very distinct flakestone traditions drawn from two distinct populations of people. There are also sites that are believed to be even older than Clovis. And surprisingly, one of these is far in southern South America, the site of Monteverde, which may date as early as 14,600 before present, earlier than Clovis by nearly 1,500 years. The site is found within a peat bog, which has allowed the preservation of various perishable materials, including timber parts of what may be structures. The location in the peat bog, however, also has opened the site to criticism of the radiocarbon dating, as a peat bog is a location where old carbon may easily migrate and contaminate the specimens to be dated. The site undoubtedly dates to the Pleistocene, however, as extinct megafauna like mastodon have been found at the site, with evidence of human butchering and transformation of their tusks and bones into tools. Here we see the remains of one of the structures at Monteverde. There's the curved clay berms that likely represent the foundations of some tent-like structure, and remnants of poles that may have supported some sort of superstructure. The raised clay berms would be used to keep water out of the interior of this structure. And while this doesn't look very convincing, there are some very convincing elements that were recovered, including stakes with cordage rope still tied to them that would have been used to hold down or hold up various poles used in the tent-like structures. Bog deposits lack oxygen within them, and therefore it allowed the preservation of many wooden and fiber objects like digging sticks, tool handles, spears, and cordage like rope and string. There was a limited amount of stone tools. There are a few flaked stone points that are lanceolate, long, thin spear points, and there were also ground stone bola stones. Bola stones are attached in sets of 3 to 3 cords that are then thrown at the legs of an animal that is fleeing. They are still used in parts of South America for hunting and for herding, as opposed to catching your llamas with a lariat. The animals that were hunted were mostly mastodon and the wild ancestors of modern llama, although some smaller game was also hunted. There are abundant plant remains recovered. 42 different species of edible plant have been identified, suggesting that these people had very detailed knowledge of their environment and the resources within it. Some of these plants may have also been used for medicinal purposes as well. Here are some of the artifacts from Mesa Verde. In the upper left on the blue background are several of these long, thin lanceolate points. Below it is a tool manufactured from mastodon tusk. The upper right are some flaked and ground stone tools. Fairly simple, not nearly the same sophistication of the Clovis stone tool assemblage. And in the bottom right is what is called a quid. It is a preserved, chewed piece of vegetable material. Sort of like the spit-out remains of chewing tobacco. But this is composed of several different varieties of plant, including kelp and other plants that may have had medicinal purposes. Kelp contains a large amount of vitamin C, and this may have been chewed in order to ingest the vitamin C and the other therapeutic qualities of the other wild medicinal plants that were enclosed within the kelp. While not found at Monteverde, throughout South America and up into Central America, the earliest type of very well-made point is the fishtail point. And you can see that it seems to combine some characteristics of the stemmed points from the Western Pluvial Lakes tradition and the fluted points of the Clovis tradition. These are both stemmed and fluted, and it may represent a synthesis of these flakestone technologies and an importation of this into South America. While much remains to be learned about Paleo-Indians in North America, even more needs to be learned about Paleo-Indians in South America. And this is an area where there's increasing research, especially in southeastern Brazil, where we will talk about unique sites with unique burials found in caves of southeastern Brazil in the next lecture section. Finally, when talking about pre-Clovis possibilities, new discoveries at the site of Paisley Caves, Oregon, need to be examined. The site was first excavated in the 1930s by archaeologists from the University of Oregon, and this was before radiocarbon dating existed. Recently, a new generation of archaeologists at the University of Oregon have returned to the site and are reanalyzing previously excavated materials and making new excavations to collect new samples in order to reassess the dating of the site. The initial excavations discovered butchered remains of Pleistocene megafauna, including horses and camels. And now we know that these come from layers that date to between 13 and 14,000 years ago, earlier than Clovis. But the most exciting discovery from the new excavations was the recovery of a human coprolite, a preserved human feces. What goes in also comes out, and it also provides organic material that can very precisely be associated with human activity within the cave, and it has been radiocarbon dated to between 13,000 and 12,400 years ago, about the same time as Clovis. Human feces also contain shed internal cells that allows DNA to be sequenced from the sample, and the DNA sequencing indicates ancestral relationship to modern Native Americans. The available archaeological evidence suggests human entry into North America about 15,000 years ago. However, the earliest sites along the Pacific coast are not able to be discovered, let alone examined, because they are now under hundreds of feet of water as a result of Holocene era rise in sea levels. The Clovis culture was long thought to be the first, resulting from migrants coming in from Asia bearing that stone tool technology. But now we believe that it was the first culture, perhaps, that began to emerge in America from earlier migrants. It was, however, also likely contemporary with other cultural and technological traditions, like the Western Pluvial Lakes tradition along the coast and in the Great Basin, that had a very different stone tool technology that was contemporary with Clovis technology. Research will continue to reveal new evidence, and it will require old assumptions to be re-examined. And it's not that earlier archaeologists were idiots and made wrong interpretations. They made the best interpretations that could be made based upon the evidence that they had on hand. An old adage in science is that I only see so far because I stand upon the shoulders of giants. The accumulated research of previous generations of scholars allow us to continue to see further, and our successors will continue to reevaluate our findings as they gather new evidence as well.